Hello everyone, this is my devlog 2 from the previous devlog. I did complete the V1 version of my compiler project, which converts C to my custom assembly-based language called GASM. So I stopped before the parser. I completed uh, the remaining parts of the parser, like the if part and the while part. While loops, I even added a for loop. To I even added for it to parse the for loop. Mm. From then I added the semantic analyzer. It was quite simple. I didn't expect it to be this simple. This was simple. I imagined something else, and it was quite logical as well. From then uh, after finishing the semantic analyzer, there were quite a few errors when doing it. That's why I needed to add some printf statements to know where it was. And then finally, the code generation part, I didn't add any fancy changing the name and printing a GASM file, but I just took an out pointer which points to the test file. Sorry, points to the C file. Sorry, points to the output file, which is here in our case it's output.gasm. Now, since the previous devlog, I added the code generation part. Here I took a different approach in code generation. Hmm. Since I have the global table, I would iterate over the global table, and I would first store all the global values into a separate function. I'd make a function which is called init globals, and I first call it to initialize all the global values. And after initializing the global values, I would call the main function. Since we know that when we run the C program, it always looks for the main first. Hence, uh, hence we need to initialize the global values first. So we make a ghost function called a ghost function which does its job. In our case, I was quite shocked. I didn't expect it to handle this way. Then we call the main function. Uh, after now the functions are generated using this part. We go through the uh, uh, global table and we check that if it is a function. Since globals are done, if it is a function, we will call gencode, which is our main function for generating the code. We go to gencode. Mm. Here it generates the code for the code in GASM for the C code. It generates the alternative code. Mm. Now all the codes are written here. Mm. I didn't expect this, but for me, the while loop and the if condition were quite same. The code part is quite same because I used such a thing for naming them. I used label. Here in my GASM code I have a opcode called label and a label name, which allows me to make a label of the name, and I can call it using the jump. I can jump to it using the jump function. So jump opcode. And similarly, for the function I used the func opcode func, which is these are all present in my GASM language. These are the different opcodes. For example, here 19 is function, and this is call. Call is this, and label is 23, and compare is sorry jump is 9. Using all this, we can jump very easily into different places, and the way I handled global variables is also quite simple. I used the hash define approach. How we how uh, Global values here are stored in a separate area called data, where it is of 1 MB size and it starts from this address, and it is 1 MB size, and I can store all the global variables in that, and the assembler does all these values, the conversions from the global names to the address, and using the push and push and peek and poke opcodes, which are used for basically they are like pointers. They can be used as pointers, peek and poke opcodes. We can easily go peek means we can see what get the value of the address, and poke means we can write to the address. Using all this, we can I generated the code for this. Uh, Now to test this is my main file, and all I did was at the end I added this part for generating the code. This is the path name for the path name for this output file, and this is the init code gen, and I can run it. Now this is my sample program, the factorial program. This uses many things like recursions. There's also if conditions here, recursions, functions, and function calls, and there are parameters and local variables and all those. And now I will execute it right now. This is this, and this is this. I'm going to compile it right now, and then this is the test.c file. I'm going to run it right now. Here we can see that everything is successed, and we generated an output file. This is the output file for this factorial one. I can even delete it and show it. I can delete it, and then I can rerun it again. Now an output.gasm file has been generated again. Now this is um, I still didn't implement, since this is V1, I still didn't implement many things like uh, printf function. I didn't write a separate code for that. I didn't implement arrays, structures, and switch statements yet. I will soon implement them, but I didn't upload them, make them yet. So I just need to replace this part which stores the value to make it print. Print is the opcode used to print the values, and load is used to load the values. This is the whole code for this. As you can see here, call initial globals, call main, halt, and this all is there. So I can explain it to uh, call init globals will call over here. The label goes over here, and there are no global variables. Hence, we'll just return back, and it returns back to over here. And we go to call main, and main is over here, and function main is over here. We push 10, and we called factorial, and factorial is over here in the function part. So we go over here, and we start this whole recursion part. uh, Here is the if else part. We will push 0, and we'll check, will jump if it is not equal. I will jump it to exit. Exit means over here. Label exit is over here. We'll skip this if part, and we'll just go over here, and we'll continue. We'll uh, this pkl and pkl is the this part, or human parameter part of since we push this here, call factor will generate three more opcodes. Since it generated three more opcodes, we should subtract three numbers size. Hence we subtract 12, which because 4 into 12, we subtract that much. We go back. We This pkl is our this part 10, and then uh, we go to that. We update it, push 1, and we subtract it, and it will become 9. We call factorial again. We do it again and again. And after doing this uh, multiple times, we can after doing this, when it becomes 0, it will push this part, push 0, j not equal. And if it is 0, it will exit. exit to over here, uh, and if it exits, uh, if it is j not equal to 0, it will exit it over here. And if it is 0, it will come over here into push 1 and store 0 and we will return. Here, the recursion will stop, and from here, we will continue from here. We'll multiply everything. We'll multiply and finally we'll return. This is our main. Now to run it, I will go into the GASM part. I will assemble and then I will compile the VM part. Now I can do this. I can use this command to generate the binary file for this for the output.gasm. This is the binary file. This is all the code for this, and then using /VM I can run it. I didn't save this. Since I didn't save I changed the print, right? I didn't save it yet, so I can't see the output. Now I will say I saved it. Now I will assemble it again. The size has been changed. Now I will run it, and I can see this value. This is this is the value for 10 factorial, and I can even change the main. Again, I can even change this part. I can change the value of 10 to 5, maybe x, 5 maybe, and I can recompile it over here using this. I can do this again. I made a new output file. I can assemble it again. Changed. And now I need to go to output.gasm and I need to print this again. Hmm. Since it's changed, I need to print this part again. Plus, and now I need to run it. First compile it and then run it. I got 120, which is 5 factorial. Now I'll try adding global values here. Suppose I can add int is equal to some 7, and I can go over here, change this part to x. Now I made a factorial function which takes the global value. Now I'll save it and I can run it over here using this part. Since this part is successful, the GASM file must have been generated, and here is it. Here it is. This global x, all the global values will be printed first. Then the call init globals will be activated, sorry, called, and we'll go over here into this label and we'll start adding the values here. We'll push 7, push global, and we'll poke. And poke will do what it will do is it will take this address, it will take this value and put this value at this address. And the rest is similar. When we push this part, it push goes into this address and gets the value and push it into stack. So we push this address and using peek we get the value of the at that address and we'll call factorial at that and the rest is the same. Here I will change it to print. Now that it prints, we can go. I can compile it in this file. I can compile it using assembler and I can run it using VM. And 5040 is the output for 7 factorial. For now, this is the state of my compiler. I will be adding arrays and stacks later.